Hello everyone, my name is Megan Evans and I will be talking about my experience doing lab activity 1, which was teacher as the student. So the lab that I chose to do was a virtual lab that was on onlinechemlabs.com, and I will put a link at the bottom of the video description so you can access this if you would like to see which lab that I have done. One of the things that was noted is you must have proper system elements to use. So one of the options was to use a Silverlight plugin. After installing that and playing around with it a little bit, Sarah, one of our classmates, actually noted that using Firefox would work as well. So then I just used the latest version of Firefox in order to complete this lab. One thing is it allows manipulation of materials. So students are able to measure out mass. One thing that I thought was pretty unique about this is you could add 1 gram at a time, you could add 1/10 of a gram at a time, you could add 100th of a gram at a time. But just as in a real lab, when you're trying to estimate to add a gram, it wouldn't add exactly 1.00 grams. It might add 0.98 grams. So it gave a realistic feel to measuring the mass, that you're not going to get exactly what you are looking for every single time. There was pouring substances, moving it from one place to a next, adding syringes, and then discarding waste. So here is a picture of the initial screen that one would see. Right here is the name of the lab. So you're looking for stoichiometric relationships with different unknown metals. One thing that you'll notice here is this table fills in with the information as it's recorded. There's record buttons throughout the simulation, and it records the data directly into here. So the student is going to see their data in this column, whereas in a few of these other columns here, you'll get the class mean, you'll get the high value, the low value, and then also a standard deviation. So as a teacher, I think that's valuable. You can use those as needed depending on the level of the class. So I think it's pretty cool. We can even get into some statistical analysis with that as well. So repeatability. The lab itself can be entirely redone. So if you will go back to this page, there's a clear all answers button that I just highlighted in yellow there. That will clear all of the data. So if for some reason the student feels as if they need to redo everything, that is an option. That would be option number 1 on that. The other thing is that individual steps can also be redone. So if a student wants to go back and realizes they may have measured a mass wrong, or they want to just double check to see what they did in the step before, there is a previous button that you can go back to other pages before, or ones that you had already accessed. So return to previous pages and access previous work. Also, it allows students to check values not placed in the physical notebook. So students can always go back and forth between the experimental screen and that data screen, this one right here. They can go back to that at any time. As a teacher, I would ask that students keep a physical notebook as well as turning in the submission electronically. So they can, if they forgot to write down the mass that they found for the zinc, they can always go back and check that as well. and then they can redo steps that may have incorrect values. Did I measure 20 grams of zinc, or did I actually measure 200 because I didn't see that decimal place there? So that is another option for repeatability. So this is the first screen that you come to. So flipping back and forth between this screen that you'll see here, this screen circled in red, is just the tab of the original data collection page. So it's very easy for a student to switch back and forth between the data collection page and the actual simulation. There's no switching, there's no having to hit a previous, it just allows them to switch between screens. So all of the materials for this lab are set up for you. The zinc and the unknowns are here. Here's some syringes full of hydrochloric acid. Down here is the scale. And then you also have a waste container. So the time. Before I actually did this lab, I did the introduction lab, which kind of gives you an idea. When you're doing this, you need to click this, drag this here. This is how you use this tool. And I'm so glad I did that. It took me about 30 minutes, but I think it saved me a lot of time with trying to mess around and figure out those options and figure out how things worked on my own. So it was a little bit extra time up front, but I think in the end it did save me a significant amount of time, I'd actually say. The actual lab did take longer than 30 minutes. It's quite heavy on the calculations end after the experiment and the simulation is done, so that took a while. So one thing that helps though is the simulation records the data. Not all of the steps were completely simple. One of the things I had difficulty with was clicking. I would click to return a bottle to its container or to its spot on the shelf, and then I'd find myself dragging it all around the screen and I couldn't get it to go back. So that is one of the places where I think it took a lot of my time, was with that issue. I think if I had not had the problems with the clicking that I did, where I couldn't get things to go back where they belonged, or couldn't drag something to the correct trash bin, or to the place to measure the pressure, I don't think it would have taken as long. It did take me about an hour total, I would say, through the calculations at the end as well. My general rule of thumb that I use when determining how long something will take a student is I do 2.5 times. I'm not sure it would take my students 2.5 times this. I think the calculations would take them longer than it took me, but I'm not sure if the problems that I had technology-wise would. I think that my students are pretty good with figuring out those types of problems, maybe better so than I am. One thing that I am concerned with is this idea of 2.5 hours for an online lab. In the discussions, a lot of us were talking about these are supposed to be things to kind of supplement and help support the learning, and when students are taking that much time to complete something like this, we have to weigh the value of their time versus the value of the education of it. So my virtual experience versus the campus experience, I would say that a campus lab is easier in terms of performance, and that simply comes back to those issues I had with clicking. It at one point took me 10 minutes to get a zinc bottle back on the shelf, and I was so frustrated. However, I think there is some value in the experience. The idea with measurements was pretty convenient, and I think it teaches students a valuable lesson in that it's hard to get exactly that value that you're looking for, which is why a lot of the times it's asking for a range. And the option that you can add specific amounts. You could add 100, or you could add 1 whole gram, which, as I said before, is going to be plus or minus off that 1. You can add 1/10 of a gram. You can add 100th of a gram. So that allowed for a little bit more convenience in the measuring, a little bit more realistic, because you can add a little bit more, you can add a little bit less when measuring the actual substances in a campus lab experience. I think that the virtual lab is very valuable for data collection. On that very first screen that you saw that I said you could click back and forth between, I think it's pretty convenient and neat that the lab collects data and it records it into a table. And not only does it record that for the student accessing it, but it takes it for all the students within that class group. So everyone from our class that would complete that lab, all of our data would go in there, and then you could do some statistical analysis on that, looking at the highest value, the lowest value, your standard deviation, your mean. So the actual data collection, I think, is very valuable, especially if you're looking at a course in which you can place an emphasis on that type of mathematics. So some issues or problems that I had, the first being the Silverlight issue, which was resolved by simply using Firefox. I'm not sure what I would have done had Sarah not figured that out for us. So prior to trying Introduction Lab, I think it would have been very difficult for me to use. So that really it wasn't an issue I had, but it's an issue I would have had I not completed that introduction. So I think that would be a very valuable experience, having all of your students complete the introduction and maybe even going through it with them as a class to kind of play around and answer questions and give them that opportunity to use the resources before they're asked to perform with them. Obviously, my clicking issues, we don't need to talk about those anymore. And then there is also a screen that I got a few times that said to contact my system administrator. It looked something like this. And what's really puzzling to me is back here, the experiment was still continuing as this error message came up. So once I hit the OK button, the experiment continued to run, and my pressure continued to decrease, which is what was supposed to be happening anyway. And I could see those numbers working in the background. I got that screen quite a few times, and it actually never had an impact on my results or my experiments, so I'm not really sure what occurred with that. So what products would I look for from my students in this situation? I generally require students to complete a lab report and a lab notebook. It's an initiative that our entire science department in our high school has done. So they're used to doing this, from physical sciences 9th graders to biology students as 10th graders, chemistry students as 11th graders, and then wherever they go, a biotechnology, biochemistry, physics as a 12th grader. They're used to completing these lab notebooks. However, I'm not really sure I would do that with this situation because of the significant discussion section that is included within the lab and is actually collected electronically, that I, as the instructor, could be able to look at. So that discussion section, I believe, is what I would have students complete. So things that they complete in that, there are stoichiometric calculations, and there's quite a few of them. So it will take them a good amount of time. I think that it will require them to do a little bit work outside of the actual completion of the lab. One thing is allows students to come back and forth, so they don't have to do it all in one sitting. So that 2.5 hours may not be 2.5 hours straight. There are also multiple choice questions, which I thought was interesting. And students are asked to justify their answer to the multiple choice questions. And it also has a minimum character count. So they can't just write yes, they can't just write no. They have to actually justify their answers, which I think is a great thing. So after looking at and completing and playing around with the discussion section, I decided this was a valuable tool, and this would actually be a good assessment without having to even create my own. So my reflection as a student, I say frustrated. I was really just frustrated with the clicking and not being able to get things to go where I wanted to go. However, there were a lot of helpful hints along the way. Things like if you cannot load your substance into where you're determining your pressure, check and make sure that your bottle is back on the shelf. So it kind of gave you hints of, if this isn't working, this might be why. And I found that to be helpful. I think that would be helpful in terms of if a student was completing this at home, the teacher would not be there to help them through that and to tell them, hey, make sure that zinc bottle's back up on the shelf. It kind of guides the student through that as well. There's also a progress bar at the top, so you can see that right here, that shows how much do you have left. We all know that our students are always going to be like, how much longer is this? How far am I? Well, it gives them a progress bar right up there. So it's not percentage wise. It's not listed as 1 out of 25 slides, but it just kind of gives them an idea. And then the last thing that I found helpful, and I think students would also find helpful, is the green screen, the red screen, and the blue screen. So right here you can see that this is in a red screen. This is what I call the red screen. This is when you're actually doing an experimental part and you are going to be using the tools on this left-hand side here and manipulating and recording and doing those such things. You saw the green screen at the very, very beginning. That's the introduction. That's just kind of giving students some background information. And then the blue screen is the discussions here. So here's our blue screen. And this is where the students are answering those final questions. So it gives them an idea of what part of the lab they are completing. So once they get to this blue screen, they know I have completed all of the experimental data. Then last but not least, these are the Ohio Revised Standards for Science that are applicable to this lab. So there are some things that we deal with gas laws within this lab and stoichiometry as well. Yes, this is how the Ohio Revised Standards are written. They are written in giant paragraph form. So if you would like to read through those, you can. Other than that, this has been my experience with the virtual lab as a student. Thank you.